Yes, I'm Radhika Rao. I'm working with Procedure, like Ulla said, for 3 months now as SDA2. I have experience in front end, back end, a little bit of cloud and a little bit of mobile engineering as well. And today I want to talk about prompt caching in React. So does anyone have any idea what it might be? Anything roughly at the top of your mind?
For example, suppose we have one web app, and on web app we have the user asks question, AI reply, please show on that.
Right.
So it takes so much time to answer that. Every time, so for example, I ask what is Kubernetes, it answers Kubernetes like tools called the cloud development. So every time the person asks, the AI will answer. So it will reduce the time. Sorry, it will increase the time.
Yeah.
So to reduce the time, we can store that answer in a caching.
Yeah.
So every time anyone asks like, what is Kubernetes? Why we use Kubernetes? What the Kubernetes is? So instead of searching directly to AI model, it will search initially
from the
on
cache.
that caching thing which
Yeah.
we are stored Redis or in our local DB store that, and then it will answer.
So prompt caching, it helps us basically save time and money. Every time you have an input, okay, and you're hitting any AI API, it's basically sending the input from the scratch, including your history, your tools, whatever you have done, it's sending everything. So we don't really need that, right? For most of the context, we don't need to send the entire context to the API, and then that might result into multiple AI calls, which can be reduced using prompt caching. So like I said, high latency, increased cost and wasted resources. What prompt caching will do is, for example, the first input that you are sending, right? You can basically tell the API that I want this prefix to be saved. I will use it later. Like I'm sending, for example, I'm a user. I have forgotten my password, how to reset my password. So I can save that, reset password. Something like that, reset password or anything in a cache. And if another user comes and says something like how to reset password, it will save time and it will, instead of sending an API request, it will directly answer from the cache. Another example for this, a little bit non-techy. If I am in a pizza shop, okay, and for every call that I make to my manager, it will cost me 10 rupees, and I'm obviously time as well, but it will cost me 10 rupees for every call I make. So there's a customer coming in and he's asking what is the cost of this margarita pizza. I'll call my manager, ask what is the cost. He will tell me, okay, the cost is 100 rupees. Okay, and in the same way, there are multiple customers. For example, there are 3 customers. So for every time I'm calling the manager and I'm asking him, so it's like 10, 10, 10, 30 rupees gone plus additional time as well. So instead of doing that, what we can do is, I can simply write it down. The price of margarita pizza is 100 rupees. So how many times I had to call my manager? Only once. So time saved, money saved. So prompt caching can be used for chatbots, documentation, RAG apps and coding assistant. It depends upon, there are different types of caching as well, and for different usage we can use different type of caching. Like there is exact match, normalized match and semantic match. Now about exact match, this will cost you the least and it is the fastest method as well. But it's not much of a use, I will say. It will return the exact, if the cache, if the key is stored exactly, then only it will send you the response from that key. For example, if I am writing as what is AI, okay, so everything should match exactly like the key that we have cached.
Even the number of spaces.
Even the number of spaces, because this doesn't trim, this doesn't do anything. This basically saves the entire key as it is. Okay, so it is fast, no API call, nothing. But this can be used, for example, if you have a personalized portfolio and there are like given questions like what are your services. So that's okay, that can send you the cached response, it doesn't have to call the API.
There different questions already, right?
Yeah, for exact match, this is a use case where you already know like what would be the possible user questions.
So like something like chatbot FAQ options where like
Yeah, already there are 3-4 questions, right? So there we can use exact match. So then there is normalized match, where this will trim the white spaces a little bit and all the punctuation capitalization, but this still doesn't understand the context. So if there is, I have forgotten my password, how to reset it, or how can I retrieve my password? This too, it will not understand. Again, normalized match will not understand. It will only understand like the example, what is the battery life, and W is small in the second example, what is the battery life. These are matched. This is okay. But for the same question, this won't be match for exact match again, because this, as it is, it should be. Now, the best prompt caching method would be semantic match.
So what is the difference with exact normalized with both the, for example, the prompt has to be same and just.
Sorry?
So what is the difference with exact and normalized? They look similar, right?
Yeah, I'm saying. So semantic match is basically, it understands context.
No, I'm asking what is the difference with exact and normalized? Because with both the
Capital W and the small W, if you know.
So that is something. So here in exact one, you will have to put the
Same normalization also, same number of white spaces also.
Everything, like even if I... Yeah,
So
please.
exact match would be, for example, if you ask question, what is the capital of India? So that is one question. And the other question could be,
What is the capital of India with different capitalization itself,
like
right?
in a passive order, the meaning is still same. You're still looking for the capital of India. So semantic is looking for meaning, exact meaning. Exact match is looking for exact
Token match.
exact word, exact character, exact
Capitalization. Everything has to be the same, including spaces and capitalization, everything. So that's the difference between both of them.
More like the password also, where you construct the
Yeah.
exact match.
Yeah.
Yeah, so if I say I got up tired, right, so that is one way of saying it. I slept less, maybe that's another way of saying it. Some might say it's exact same meaning. So something like that. So might not be exact same words. There might not be even one exact same word, but meaning is still the same.
Sentimental meaning is same.
Yeah.
Yeah. So in the semantic match, this is where the actual prompt caching would work for more applications. Even if you paraphrase the sentences, even if you change the sentences, like Ullas said, like it will still understand like what we want. For example, again, like explain thermodynamics or how heat energy works. This would be cached in the semantic match. So this is the most powerful but also expensive and time consuming, because this would take some time to search for the context and give you. So semantic match in production level apps, ideally all the three should be used. First obviously would be exact match, then normalized, and then semantic if necessary.
Yeah, so semantic match also saves the context about entire chat.
Entire chat, yeah, if you want, yeah.
Yeah, like
In the
for
cache.
example, we didn't handle this case, so I suppose I don't know about social media, I said what is Facebook, I asked the question and then on the chat bot, and then I asked how to create an account. If I don't pass the context how to create an account, the cache where the cache would search, because how to create an account, you can create an account in multiple ways.
So it would give you the closest one. For example, if you're using an application in the company and there are like 4 or 5 people, so we know that we are talking about that application, particular application. So it would give you how to create an account in that particular application. So for every cache we can, for every application we can create a cache, so it can answer based on for that application. So in semantic match there is something called as vector embeddings, where it basically, vector embedding is, it basically saves your words or whatever in numbers in the vector database. So when we are basically caching it, we can also mention the time we want that to live in your application. Like for example, I think in Claude or in Claude there is for 1 hour. The context is saved for 1 hour, but in our application, I don't think we want, I mean, ideally, it's like 5 minutes TTL. That's enough, and after that, that cache is destroyed, because again, it's taking the time, it's taking the space as well. So if you can see in the cache control, type ephemeral. Ephemeral is basically it's saying it's temporary. The meaning is, it says that this cache is temporary, and we can set up for 1 hour or 5 minutes. 5 minutes is ideal, but we can also save for 1 hour as well. And we can customize it according to our application. If we want, for example, if we have a e-commerce website and we want to save certain recommendation, if you have used Myntra and Amazon, I know it's in Myntra. So if you use like AI bot there to suggest me some summer outfits, I've done that. So it suggests you some outfits, AI recommendations. So that maybe we can save it for 5 minutes, or we can destroy it when the app is closed, something like that. So we can customize it as well.
So the caching will work for same user asks a prompt again and again, right?
No, it would be saved at the server level so that it can help all the users who are using it.
Then why 5 minutes? Because there could be users who might come like for like weeks and asking what is summer outfit.
So it will be sending again. But if example for I have stored it for 1 hour, like I don't know for how long Myntra caches it, but let's take it for 1 hour. I have searched summer outfits, someone else also has searched summer outfits. So it would send cached response to that. But yeah, if after one, they will have to send a API call again.
Then it depends on the cost of that call itself, right?
Yeah.
The cost of storing that cache versus cost of making that call again is what the trade-off there would be. Then.
So it would be better if within an hour, like Myntra is widely used. There are chances that it might be, the same prompt might be used by a lot of people. It won't be like just summer outfits. You can say something for you. Anything close to it, it will return the cache.
The model is cache it itself, or you have to define the category. You have to cache this word or something like that.
It depends.
First time a user is on the search for that, I'm doing some outfit. The model, the cache itself.
Sorry, I didn't get
We
it.
have not reshaped the model. This is before model caching mechanism.
Yeah.
But the
It's,
caching will happen for on its own.
On the website level.
it's the application, it's in the application level.
Yeah, but I understood, but then, how would the system that we have to cache this? Or we have to, or we cache it as manually?
Just a second.
So the code what you write, it depends on that. What caching mechanism you need as a designer, you will decide based on the nature of the application.
If you want to cache a certain word, one sentence is enough. That's fine too, and it can return that, like that.
So ideally should be a function of how frequently your output is likely to be changed, right? If the output changes, say, within 1 hour or 1 day or whatever, then you can decide what, because with the same input you can have different output.
Yeah, based on your application usage. Like I said, like if there is an application used by all the people here, there might be a lot of same questions as well, right?
Take a cricket score, for example.
Yeah.
Tell me what is the score. So after every ball, it has to change.
Yeah.
Right.
So yeah, that is the case I was going to mention. There are some AI application where this won't work. Like something like if you have a like documentation application where you have to make a summary of something, or you have to make a like form, you have to fill a form where you have to, anything that might be changing constantly, that's where prompt caching won't work, because it will be new every time. This question was asked by in the React Mumbai. This was really interesting, and I looked into it. That one con of prompt caching is it cannot be used for applications where every prompt might be new. So that's where prompt caching won't work, and you will have to call the API for every prompt. So this is an example. In the messages, there can be another message which you might not want to cache. Like anything you want to cache, you have to pass cache control and the time if you want, or I think that for every model there is a default TTL. For ChatGPT, I think, correct me if I'm wrong, I've used it once, 5 minutes TTL. So for every API model, they have their own TTLs.
So another question is that is there any like TTL extension mechanism? Because for example, if multiple users are asking the same question, so does that TTL get extended, or does that get reset every single time the question is asked, or is it from the first time that specific API call was made for that specific question?
So there is custom TTL. We can set it up, we can test it, like we can survey like how much repetitive questions are there, and we can set it accordingly.
Normally every caching system will have some kind of invalidation strategies. For example, least frequently used is one. Last used, like when was it last used, that is one. For example, when was it first used, that could be one case. So there are different strategies. So for example, if something is being used again and again, it won't be invalidated. something is used, maybe say there might be hard cases like 300 seconds invalidating the how, right? So depends on what strategy you use, depends on what writing strategy you also use for caching. For example, in this case, what he said was what is the live score right now. So you won't try that to cache, but if something is being said 3 or 4 times and the answer is still the same, you might start caching that, right? So it depends on what strategy you are using for writing and also for invalidation. So you have fine control on that, you can control if you want to. Even if it's not in the documentation per se, but you can still work around that, you can still write code.
Application level
Code, and then you can still cache it.
In React, we have time stack query for caching the API endpoints,
Right.
which we feel would be called repeatedly, and we cache output based on keys. So here we know these questions would be asked frequently, so we cache it. So the developer designs it in such a way that I as a developer know these questions would be asked for the product and told me that these questions are asked frequently, please cache these particular questions.
Right.
So if tomorrow we come to know, okay, these XYZ questions are being asked continuously, is there any method so that it dynamically starts caching it as well?
Semantically, we could have different pathways for different types of questions. So for example, you could classify the question, what kind of questions, and if you think that these kind of questions can be asked frequently, you can have a different path for caching those kind of questions. So completely up to developer how they want to do it, but having a classification layer before you decide to cache it out would be a good strategy for you. So in case of time cycle, it's quite simple because the URL is in the present change, right? So it's very easy to cache that. If it's the same URL, just use it from the past query I've used. But in case of this, you might want to use some kind of classifier wherein, and with the product manager as well, okay, these are the kind of questions I need to cache for. For example, if there's a live score match question, you can't really cache that. So you need to classify what kind of question it is.
Yeah.
Okay, so we create a hash map with the direction and the question tag.
Not really. I mean, what you normally cache is the answer. That's right. You normally cache answer, you don't cache the question. So you automatically kind of make sense of if this is the same question or not, and use kind of a small language model for that before turning it out a bigger language model. But normally what you would do is you would cast the answer and then you would try to figure out if this answer is matching the question that I've asked. And if it has some confidence, you might give that particular answer, right? So you're not really caching the questions as such.
Got it.
Only charge for the detail or for the first time when they store in the cache and the multiple URL are accessing it, that also cost.
The first one. The first API call is always, it would be expensive irrespective you apply prompt caching or not. Prompt caching is just saving you multiple API after the first call, but first call has to be made. So that's the cost to the company.
But how does the cache save? Like it is the LLM based, like we do the custom code or LLM itself store the cache.
That's what my question was. Yeah.
It basically stores the response from the LLM.
No, but like how we define the caching mechanism? Is it
Key value.
Like it is inside the LLM or do we need to?
No, we can save it in Redis as well.
Okay.
Yeah. So that is the preferred method. That's what I have implemented. I have set it in Redis. And if it's for learning perspective, you can also store it in local storage as well. If you are just learning how to implement prompt caching, that's something you can do.
The example you got showed, it was like using something like OpenAI.
Yeah, that's application level, yeah. So one thing about semantic matches, I forgot about the thresholds. You can have a threshold for the kind of match you want. Like it's from 0 to 1. Okay. So if for example semantic match is returning a match is around 70%, 75%, but I have set a threshold of 0.90. I wanted to match like 90% of the times, then only it should give me the cached response or it should call the API. So we can set a threshold for semantic matches as well. So this is a very important point. Like the match caching for the content, ephemeral is for dynamic and short-lived. There should be TTL based also for how long you want. And then there is also conditional for complex scenarios. You need more customization as well. I have sent a prompt, okay? And there is no hit for exact match, but we get a cache hit for semantic match. But I found out that my application has still called the API again. There is still an API call. So why do you think anyone?
Because the threshold is
The score you mentioned.
There's a lot more to go in semantic caching. So if you all want, I can share you some blogs that I've gone through. There's a lot in it. So I'll definitely share that blogs with you. Thank you.
very